Next, we'd like to look at compositions of functions. A function composition is where we apply one function to the result of another. For example, if I take this function g and I am substituting something in for g, we'll say x. When I take x, which is my input, and evaluate it through the function g, we get a result or an output of g of x. Again, my input is my domain of g. My output is going to be my range of g. Well, let us assume that we're taking this output, g of x, and I'm going to take that output and put it right back into another function, f of x. So my input of f will be the same as the output of g. When I plug g of x into f, I'm getting f of my input, which my input now is going to be the result of g of x. This is my new output. My domain of f is going to be the same as the range of g of x. So let's go back and read this one more time. Function composition is applying one function to the result of another. So if I'm applying f to the result of g, this is going to get me a function composition. And this output, f of g of x, is what we will be finding when we're looking for compositions of functions. So now let's look at the definition. Given two functions, f of x and g of x, we can determine f of g of x, and that's how we pronounce this, f of g of x, written this way or this way, is both pronounced f of g of x, means to substitute g of x for all the x's in f of x, and then simplify. G of f of x, which is pronounced g of f of x, means to substitute f of x for all x's in g of x. Again, we must simplify. Notice that in each of these cases, we are looking at the inside function first. You take the inside function and substitute it into the outside function, which makes sense because in PEMDAS we work inside to out with our parentheses. So given this first example, f of x is equal to x minus 7 and g of x is equal to x squared plus 2, we're asked to find the following. Note that in the first problem, we're asked to find f of g of x, and then right below it, we're asked to find f of g of 3. So sometimes we're asked to find the composition of functions in terms of x, and sometimes we're asked to find the composition of functions given a certain value. For these examples, I'm going to use f of x is blue and g of x is green. So for f of g of x, I'm going to rewrite this as f of g of x. I'm going to take out the g of x, and instead of g of x, I'm going to replace what g of x is equal to in its expression form, which is x squared plus 2. Now I would like to find f of this expression. We actually have found f of expressions in the previous lesson. So in order to find f of an expression, I take the expression f, which is x minus 7, but instead of the x value here, I take out the x and I replace x with who's ever inside the parentheses, in this case x squared plus 2 minus 7. Therefore, f of g of x is equal to x squared, combining my constants, minus 5. So this is my new function, f of g of x. Let's turn this problem around and try to find g of f of x. So in this case, I have g is being composed with f. My g function is on the outside, so I'll take care of him in a minute. First, I'd like to focus on the innermost function, f of x. And who can I replace in for f of x? Well, in this case, f of x is equal to x minus 7. So I'm going to take out the blue f of x and replace it with the blue x minus 7, because they're equal. Now I'm trying to find g of this expression. Well, I know the g of x function says x squared plus 2. But I'm going to take out the x, and I'm going to substitute, in every place I see x, I'm going to substitute whatever's inside the parentheses, the expression x minus 7. Now this actually can be reduced, so I'm going to do that. I have x minus 7 squared, which I'll need to write twice and double distribute. Some of you may have that formula memorized and you can do this in your head. Some of us may not. So this is equal to x squared minus 14x when I'm combining my x values. Combine my numbers and get 51. So g of f of x is equal to x squared minus 14x plus 51. Are these expressions the same? Is f of g of x equal to g of f of x? Well, no, they're not even close to being the same. So I just wanted to emphasize that they are not the same. Sometimes they may be the same, and we'll talk about that in the next lesson, but in this case they are not the same, and oftentimes they are not the same. So you have to be careful in which the order in which you see the functions being composed. Now next we see f of g of a number, in this case a number 3. So when I'm trying to find f of g of 3, I actually have two methods that I'm going to be showing you. To find f of g of 3, I can use my function that I just found, f of g of x, to find f of g of my new value 3. When I use the function that I just found, all I have to do is replace x with the 3. So in this case, I have x squared minus 5, and when I replace x with 3, I'm getting 3 squared minus 5, which gives me 9 minus 5, or 4. Therefore, f of g of 3 is equal to 4. This is a very easy method when you've already solved f of g of x. Although sometimes you may not have been asked to find f of g of x first. You may just be asked to find f of g of 3 right off the bat. You can do this as well in parts. Let's just look at the middle part right here. If I'm trying to find g of 3, I can use my original g function to find g of 3, which is 3 squared plus 2, or 11. So g of 3 is equal to 11 just using my original g function. If I'm taking the 3 and plugging it into g, I'm getting out 11. But now I need to compose that function with f. In order to find f of g of 3, which is what I was really asked to find, I know I can replace g of 3 with 11, because g of 3 is equal to 11. Now I can solve by plugging 11 into the function f. So f of 11 is equal to 11 minus 7, or equal to 4. So f of g of 3 is still equal to 4. Is it the same answer? Of course it's the same answer, because it's the same problem. I'm just using two different methods. Method 1 is very easy if you've already solved f of g of x. Method 2 is very easy if you don't want to do the work of f of g of x, if you just want to find f of g of just some number, 3. Plug 3 into g, take that result and plug it into f. For our next example, I'm trying to find g of f of 3. Again, for my first method, I can find g of f of 3 by plugging into g of f of x and just replace x in my function with 3, which gets me 3 squared minus 14 times 3 plus 51. 9 minus 42 plus 51 is equal to 18. So g of f of 3 is equal to 18. Using the second method, if I haven't already found g of f of x, in order to find g of f of 3, I'm just going to do this in parts. Let's just look at the inside first and find f of 3. To find f of 3, I need to use my original function f, which is x minus 7. In this case, 3 minus 7, or negative 4. Notice this is not the answer because I haven't actually solved for g of f of 3. So g of f of 3, and f of 3 can be replaced with negative 4. So what I'm really asking to do is to find g of negative 4. Well, I have the g original function here in the top. The g of the original function says x squared plus 2, but instead of x, I'm going to plug in negative 4. Negative 4 squared is 16, plus 2 is equal to 18. So g of f of 3 is equal to 18. Notice it's the same answer. And it's the same answer because we were asking the same question, just using two different methods. You can use either method that you like, or you could use one method if you found f of g of x previously, one method 2 if you haven't found f of g of x previously. I have one more example for you. We'll use f of x for red and g of x for purple this time. So in order to find f of g of x, I have to substitute g of x with the square root of x minus 4. I'm taking the result of g of x and I'm composing that with f of x. So I'm taking the square root of x minus 4 and substituting it into f of x. F of x is x squared plus 2, but I'm replacing instead of x the square root of x minus 4. Reducing, I get x minus 4 because the square root and the square are opposites and they cancel each other out. I'm getting x minus 4 plus 2, or really just x minus 2. Therefore, f of g of x is equal to x minus 2. Next, I'd like to find g of f of x. To find g of f of x, I'm first going to substitute the innermost function f of x with its expression. I won't do anything with g of x for the moment. F of x can be replaced with x squared plus 2. Now, g of a function is something we've already done before. Now, g of an expression is something we've already covered before. My g function says the square root of x minus 4. But instead of the x, I'm taking it out and replacing x with x squared plus 2. I know that this can be reduced. X squared plus 2 minus 4 reduces to minus 2. So therefore, g of f of x is equal to the square root of x squared minus 2. Again, clearly these are not the same, which means you have to be careful of the order f of g of x or g of f of x. The order really does matter here. To find f of g of some value, in this case we're finding f of g of 5, I have two methods again. If you already have found f of g of x, the easy method to find f of g of 5 would just be to plug 5 into that function that you've already found, which is x minus 2, or in this case 5 minus 2. Therefore, I know f of g of 5 is equal to 3. Very simple solution if you've already found f of g of x. Although if you haven't already found f of g of x, in order to find f of g of 5, I will first find the innermost function and evaluate g at 5. Notice I'm evaluating g, so I'm using the original function g, which is the square root of 5 minus 4, or the square root of 1, which is really just 1. G of 5 is equal to 1. That is not my answer. In order to find the answer, I'm going to find f of g of 5. And I know g of 5 is equal to 1, so really I'm trying to find f of 1. I can do that by plugging 1 into my original f function. My original f function said x squared plus 2, but now I'm using x is equal to 1. 1 squared is 1 plus 2 is 3. Therefore, f of g of 5 is equal to 3, which is what we said here earlier. Lastly, to find g of f of 5, if I have already found g of f of x, to find g of f of 5, all I do is substitute 5 in to my g of f of x function, which in this case is the square root of 5 squared minus 2, or 25 minus 2, the square root of 23. Therefore, g of f of 5 is equal to the square root of 23. Although if I haven't already found g of f of x, then this method wouldn't be very easy if I don't have a function to plug into. I can still find g of f of 5 by finding or evaluating f of 5 from my original function f. My original function says x squared plus 2, but I'm using x is equal to 5, which gets me 25 plus 2, so f of 5 is equal to 27. To find the question that was being asked, g of f of 5, I'm going to evaluate g at f of 5, but f of 5 can be replaced with 27 because f of 5 is equal to 27. Now all I have to do is take 27, the result from my first function, and plug it into my second function, or my outer function, g of x. My g of x function says the square root of x minus 4, but I know my new x is 27. The square root of 27 minus 4 is equal to the square root of 23. Therefore, g of f of 5 is equal to the square root of 23. Notice it's the same as the other solution we got using method 1. This concludes our section of operations of functions. First, we found domain of an equation. Next, we found new functions by combining functions. And lastly, we found new functions by composing two functions.